See the solutions for Assistant Professor Electronics and Telecommunication Engineering conducted by Assam Engineering Services Recruitment Board in the year 2023. First question. If the capacitor is energized by a symmetrical square wave current source, then steady state voltage across the capacitor is. So we know that the voltage across the capacitor is given by Vc of t is equal to 1 by C integral I dt, where IC is a current flowing through the capacitor, Vc is a voltage across the capacitor. During positive half cycle of the symmetrical square wave input, voltage across the capacitor increases linearly. Similarly, during negative half cycle of a symmetrical square wave input, voltage across the capacitor Vc of t decreases linearly. So this linearly increasing and linearly decreasing waveform, it contributes to a triangular wave. So that is square wave, symmetrical square signal applied to a integrator. Capacitor is nothing but a integral of current. So that is integrator, it generates triangular waveform. Triangular wave. Next question. The coupling between two coils is said to be ideal. So ideal coupling or perfect coupling if the coefficient of coupling is 1. So generally the definition for this coefficient of coupling is the fraction of magnetic flux produced by the current in one coil that links with the other coil, or the amount of coupling between two inductively coupled coils. This coefficient of coupling, it is represented with K and it lies between 0 and 1. If K is 0, there is no coupling, that means the coils are magnetically isolated. If K is 1, perfect coupling. For K0, no coupling or coils are isolated. For K is equal to 1, it is perfect coupling, that is all flux produced by one coil links with the other coil. Therefore correct option is C. If two coils have ideal coefficient of coupling, so that is perfect coupling, it is K is equal to 1. Next question. 4 resistances 80 ohm, 50 ohm, 25 ohm and resistance R are connected in parallel. The current through 25 ohm resistor is 4 ampere. The total supply is 10 ampere. The total current here is 10 ampere and the current flowing through 25 ohm resistor is 4 amperes. Then what is the value of resistance R? As per the question, the circuit diagram is drawn like this. So from this circuit diagram, the current flowing through 25 ohm resistor is 4 amperes. So from this voltage across this terminal VAB, so voltage across this A and B is resistance into current, that is 100 volts. Now this all the resistors 25 ohm, 50 ohm, again 80 ohms, here it is 80 ohm, 80 ohm, 50 ohm, 25 ohm and resistance are all in connected in parallel. So that means once these resistance are connected in parallel, the voltage across the resistance is fixed. Therefore current flowing through 50 ohm resistor is current flowing through 50 ohm resistor. So that is VAB, voltage across A and B, that is 100 volts by 50 ohm, it is 2 ampere. Now voltage flowing through this 50 ohm is 2 ampere. Similarly, voltage current flowing through 80 ohm resistor, so that is 100 by 80 ohms, 1.25 ampere. So this current is 1.25 ampere. Now the total current is, apply KCL for this node, sum of entering currents is equal to sum of leaving currents. So therefore total current I is 10 ampere, it is equal to 1.25 ampere Apply KCL, Kirchhoff current law. So incoming current is 10 amperes. It is equal to 1.25 ampere plus 2 ampere plus 4 amperes plus current through let IR be the current through R ohm resistor. So this current is IR. Now from this KCL expression, the current IR is 10 minus 4 plus 2 plus 1.25, 7.25 ampere. So that is 2.75 ampere. Now current flowing through the resistor R is 2.75 ampere. Now the voltage across this R is 100 ohms. Voltage across this resistance R is 100 volts. Resistance R is voltage by current. So voltage is 100 volts and the current that is obtained is 2.75. So from this resistance value is 36.36 ohms, approximately 36.36 ohms. It is 36.3636, it is repeating, hence 36.36 ohms. Correct option is C. Next question. In a linear network, the ratio of voltage excitation to current response is unaltered when the position of excitation and response are interchanged. Here excitation means source. If the position of source and response, that is load. If the position of source and load are interchanged, then the ratio of voltage excitation to current response is unaltered. It is a statement for reciprocity theorem. This reciprocity theorem states that in a linear, passive, bilateral, time invariant network, the current in one branch due to a voltage source in another branch is same if the position of voltage source and the measured current branch is interchanged. Or in a linear, passive, bilateral, time invariant network, the current in any branch due to the source is equal to current in that branch where source was originally placed when the source is moved to the branch where initial current is measured. These are conditions for reciprocity theorem, and this reciprocity theorem is applicable only when there is a single independent voltage source in the network or single independent current source in the network. The presence of dependent sources make the network inactive. So this is applicable only for passive networks. The presence of dependent sources make the network inactive. Hence reciprocity theorem is not applicable. Next is, you just take a note of this superposition theorem. This superposition theorem states that in any linear bilateral network having multiple independent sources, the response across any element in the circuit is equal to algebraic sum of responses of that element by considering each source at a time, provided the remaining sources are replaced by their internal resistances. As per the question, the correct option is reciprocity theorem, and this is a condition for where the reciprocity theorem is valid. So it is valid only for independent voltage source or independent current source is present in the network, and presence of dependent sources make the network inactive. Hence this reciprocity theorem is not applicable. Next question. There are no transients in pure resistance circuits because circuits containing only resistive elements have no transients. Only resistive elements doesn't have any transients because resistors doesn't store any energy. The transients occur because energy cannot be destroyed suddenly. These L and C components have stored energy where resistor cannot store energy. Resistor cannot store energy. So the reason is there is no energy storage in the resistor, hence there are no transients in the pure resistive circuits. Next question. Resonance occurs in series RLC circuit at resonant frequency of omega naught is equal to 1 by root LC. This assertion is correct. The impedance of the circuit at resonance is maximum. This is wrong. So at resonance, impedance Z is minimum. So Z is minimum. Impedance Z is minimum at the resonance, and the minimum at resonant frequency impedance is minimum, and the minimum value of impedance is equal to resistance, because at resonance at resonance. XL, inductive reactance is equal to capacitive reactance. Therefore, impedance Z is equal to resistance, which is minimum value, least value. Therefore, from the graph also we can say that at impedance, so this is the resonant frequency. At resonant frequency, omega or resonant frequency, XL is equal to XC. Both reactants cancel each other. Therefore, impedance value is minimum. This is x-axis is frequency and y-axis is impedance. So, impedance minimum at resonant frequency, and frequency is below minimum frequency, resonant frequency, impedance increases. If frequency is increased above resonant frequency, again impedance gets increased. And the nature of impedance, which is dominating above the resonant frequency, is inductive nature, and the nature of impedance, which is dominating below the resonant frequency, is capacitive nature. Next question. A series RLC circuit consisting of resistance 10 ohms, inductive reactance XL is equal to 20 ohm, and capacitive reactance XC is 20 ohms. It is connected across a AC supply voltage of 100 volts RMS. The magnitude and phase angle with respect to voltage across the inductive coil respectively is. So in the question they have given series RLC circuit with resistance 10 ohm, inductive reactance 20 ohm, capacitive reactance 20 ohm. So clearly it has been mentioned in the question that XL is equal to XC. Therefore, circuit is at resonance. Circuit is at resonance. At resonance, impedance is resistance. Impedance, the value of impedance is equal to resistance. Therefore, current flowing through the circuit is I is equal to V by Z. So that is V is 100 volts RMS by the value of resistance. Z is equal to R. This Z is equal to R at resistance, and the value of this resistance is 10. So therefore, current is 10 amperes. Now the voltage across inductor VL is equal to inductive reactance XL into current I. So this inductive reactance XL is equal to J omega L into I. So J omega L into I. In the question they have given inductive reactance XL is 20 ohms. So that is J 20 into current, that is 10. So 200 J. So it can be written as 200 at an angle of 90 degrees. If it is capacitor, then VC is equal to voltage across the capacitor, VC is equal to 1 by J XC into I. So it will become 200 at an angle of minus 90 degrees. So this is voltage across the capacitor, and voltage across the inductor is 200 at an angle of 90 degrees. Now the correct option is D, 200 volts. Voltage across the inductor is 200 volts, and the phase angle is plus 90 degrees. Next question. In a two-port network, the condition for reciprocity in terms of H parameters and ABCD parameters. So let us see the definition of the condition for symmetry and condition for reciprocity. So reciprocity states that a network is said to be reciprocal if the ratio of response to excitation is invariant, so it doesn't change with time, to an interchange the positions of excitation and response in the network. Even though if position of source and load is interchanged, the ratio of response to excitation is invariant, so it doesn't change. Next, the condition for symmetry. So the network is said to be symmetrical if the input and output ports are interchanged without altering the two-port voltages and currents. Next, so different Z parameters are given and the conditions for symmetry and reciprocity is mentioned. So for Z parameters, condition for symmetry is Z11 is equal to Z22. Similarly for Y parameters, condition for symmetry is Y11 is equal to Y22. For H parameters, delta H, the determinant of H parameter matrix is 1. For G parameters, delta G is equal to 1. So similarly reciprocity, Z12 is equal to Z21 for Z parameters, Y12 is equal to Y21 for admittance parameters, H12 is equal to minus H21, G12 is equal to minus G21. These are the conditions for symmetry and reciprocity for different parameters, transmission parameters. So in the question they have asked H parameters, condition for reciprocity for H parameters, hybrid parameters and ABCD parameters. The condition for reciprocity for ABCD parameters is AD minus BC is equal to 1, and for H parameters it is H12 is equal to minus H21. H12 is equal to minus H21 and AD minus BC is equal to 1. This is a condition for reciprocity in terms of H parameters for and ABCD parameters. Correct option is D. Next question. A balanced load of 5 plus 4j is connected in delta. Then what is the impedance per phase of equivalent star connection in ohms? So let us see how to transform this delta network to star network and star network to delta network. So these conversion formulas are given below. If in this network, if this R1 is equal to R2 is equal to R3 and RA is equal to RB is equal to RC, then the relation between star to delta connection and delta to star connection is R delta. Resistance in delta is 3 times of star resistance in star connection. R resistance in star connection is equal to resistance in delta connection by 3. In the question they have asked, the balanced load is connected in delta. So in delta connection, the impedance value is, so Z delta impedance value is 5 plus 4j. They ask to calculate the value of branch impedance in case of star connection. Therefore, Z star is equal to Z delta by 3. So 5 plus 4j by 3. So that is 5 by 3 plus 4j by 3. So 5 by 3 is 1.666 plus j into 1.333 ohms. So correct option is B. Next question. In a sinusoidal oscillator, sustained oscillations will be produced if the loop gain is. So according to the Bark-Hassan criteria, it states that as per Bark-Hassan criteria, it states that the magnitude of open loop gain of amplifier A and feedback factor gain is unity. It should be unity. If it is greater than 1, the oscillations are continuously growing. If this less than 1, the oscillations will decay. If it is equal to 1, the oscillations are sustained. And one more condition is the total phase shift around the closed loop is 360 degrees or 0 degrees. Satisfying these two Bark-Hassan criterions, the circuit will work as an oscillator producing sinusoidal oscillations, sustained oscillations with constant frequency and amplitude. So correct option is A. So the magnitude of loop gain A beta should be equal to 1, that is unity. Next question. In an electric circuit with 10 branches and 7 nodes, we'll have how many loop equations? So the number of loop equations or number of mesh equations or number of current equations is given as B is equal to n minus 1. So it is given as B is equal to B minus n plus 1. So that is number of branches given here is 10 branches and there are 7 nodes plus 1. Therefore number of loop equations is 4. 4 loop equations or 4 mesh equations or 4 current equations. Correct option is B. Next question. For a voltage series feedback. So voltage series feedback is also called voltage amplifier or series shunt topology. So this voltage series feedback is also called series shunt topology or voltage controlled voltage source. So here input is voltage, the mixing input is mixing is voltage. So at the output we are performing sampling and voltage is sampled as well as voltage is mixed. So input is voltage, output is also voltage. Examples for this voltage series feedback or series shunt topology or voltage controlled voltage sources: common collector amplifier or emitter follower, non inverting amplifier, and common drain amplifier. So common drain amplifier is also called source follower. These are the examples for voltage series feedback. So in this voltage series feedback, input impedance Ri increases and output impedance Z0 decreases. Therefore, correct option is A. Next question. The voltage gain of amplifier without feedback and with negative feedback is 120. So in the question they have given voltage gain with negative feedback. So it is represented with AF, it is 20, and voltage gain with positive feedback, it is 100. So we know that they ask to calculate the value of feedback factor, feedback network gain, that is beta. So we know that closed loop gain AF is equal to A by 1 plus A beta. So in the denominator there is a plus symbol because it is a negative feedback. If the feedback is positive, in denominator we will write 1 minus A beta. So they have given AF is equal to 20 and A is 100, 1 plus 100 into beta. So on calculation the value of beta is 0.04, that is 4%. Correct option is C. Next question. The differential gain of operational amplifier is 400 and the value of common mode rejection ratio is 150. So given differential gain is 400, a common mode rejection ratio is 150. What is the value of output voltage when two input voltage are 200 microvolts and 160 microvolts respectively? So here they have given we input voltages, voltage applied to inverting terminal as well as voltage applied to non-inverting terminal V1 and V2, 200 microvolts, 2000 microvolts and 160 microvolts. So from this we can able to calculate the differential voltage, that is difference between two voltages. Differential voltage is 200 microvolts and 160 microvolts. So differential voltage is V1 minus V2, that is 200 minus 160, 40 microvolts, and the common mode voltage is V1 plus V2 by 2, 200 plus 160 by 2, that is 360 by 2, Na 180 microvolts. Common mode voltage is 180 microvolts and differential voltage is 40 microvolts. Now the output voltage. This output voltage expression is given as AdVd into 1 plus 1 by CMRR, common mode rejection ratio, into Vc by Vd. So substitute the values given here. So that is differential gain Ad is 4000 and differential voltage Vd is 40 micro, 40 into 10 power minus 6, 1 plus common mode rejection ratio, its value is 150 into Vc, common mode gain, that is 180 microvolts by differential gain 40 micro. So on solving, its value is 164.8 millivolts. The output voltage is 164.8 millivolts. Next question. The voltage gain of an amplifier is 100. Negative feedback is applied with feedback factor gain 0.03. The overall gain of amplifier is, so in the question they have given voltage gain of an amplifier, open loop gain is 100 and feedback factor gain is 0.03. The feedback given is negative feedback. So the overall gain of amplifier is given as AF is equal to A by 1 plus or minus A beta. So plus symbol for negative feedback and minus symbol for positive feedback. In the question they have given negative feedback. So that is overall gain is AF is equal to A open loop gain, that is 100, 1 plus A beta 100 into 0.03. So it is 100 by 1 plus 3, its value is 4, 100 by 4 is 25. So closed loop gain value is 25. Correct option is C. Next question. The amplifier has input power of 2 microwatts. The power gain of an amplifier is 60 dB. What will be the output power? So in the question they have given power gain. So power gain means 10 log of 10 log. So 10 log for power gain or attenuation, 20 log for voltage or current. Okay. So power gain has been mentioned and the input power PI is 2 microwatts. power gain is 60 dB. So that is 10 log of power gain. Power gain is output power by input power. So that is output power by input power. Power gain is P suffix gain is P output by P input. So that is 10 log of P output by P input is equal to 60 dB. That is P naught by Pi. Output power by input power is equal to 10 power 0.10 power 6. Output power by 60 by 10 is 6, and it can be 10 power 6. So that is output power is equal to P naught is equal to 10 power 6 into input power, that is 2 into 10 power minus 6 watt. Now the output power P naught is equal to 2 watt. The correct option is D. Next question. In a class A amplifier with maximum voltage of 15 volts and minimum voltage of VCE, collector emitter minimum voltage of 1 volts, what will be the conversion efficiency of series fed load? So this conversion efficiency of class A power amplifier with series fed load is maximum, it is 25. So this is ideal value, which is 25, but in the question they have given 15 volts VCE maximum and 1 volt VCE minimum. So that is efficiency is, so 15 minus 1 by 15 into 25%. So its value is 23.33. 25 into 14 by 15. So which results? So this is 14 by 15 into 25%. Its value is 23.33%. So correct option is B. So let us see some more points related to class A power amplifier. So in class A power amplifier, transistor operates in active region at all the times. Conduction angle is 360 degrees and maximum efficiency is 50%. This is for transformer coupled class A power amplifier. For series fed class A power amplifier, the maximum efficiency is 25%. Next, figure of merit for class A power amplifier is 2, and this is a power amplifier which produces least distortion in the output among all power amplifiers. So the power amplifier which is having least distortion is class A power amplifier, but the conversion efficiency is low. Next question. Correct option here is B. Next question number 18. A two-stage amplifier is required to have an upper cutoff frequency of 2 MHz and lower cutoff frequency of 30 Hz. So given number of stages is 2 stage amplifier, therefore number of stages n is equal to 2, and upper cutoff frequency for this two stage amplifier is 2 MHz and lower cutoff frequency for this two stage amplifier is 30 Hz. And what will be the lower cutoff frequency and upper cutoff frequency of individual stages approximately? So here formulas are mentioned. The upper cutoff frequency fh star is equal to fh square root of 2 power 1 by n minus 1, and lower cutoff frequency fl star is equal to fl by 2 power 1 by n minus 1, where this fh and fl represents higher and lower cutoff frequency of individual stages. Fh star and fl star represents higher and lower cutoff frequency of multi-stage amplifier, and the overall gain is product of individual gains. Overall phase gain is sum of all individual phases, whereas bandwidth for n stage amplifier BW star is equal to bandwidth of single stage amplifier multiplied with square root of 2 power 1 by n minus 1, where n is the number of amplifiers in the multi-stage amplifier. In the question they have given fh star 30 MHz and fl 2 MHz. fl is 30 Hz. Sorry, fh star is 2 MHz and fl is 30 Hz, and we need to calculate the value of fh and fl. So therefore fh star is equal to fh square root of 2 power 1 by n minus 1. So that is fh star is 2 MHz, 2 into 10 power 6 fh 2 power 1 by n, that is the value of n is 2 root 2 minus 1. So the value of root 2 is 1.414 minus 1, square root of 0.44. So on calculation, its value, higher cutoff frequency fh will come, its value is 3.1 megahertz. Next question. In the same question, fl star is equal to fl by square root of 2 power 1 by 2 minus 1. The given FL star value is, so that is lower cutoff frequency of multistage amplifier is 30 Hz. So from this lower cutoff frequency FL is equal to 19.3, so approximately 20 Hz. Now the correct option is 20 Hz and 3.1. So the nearest value correct option is 3 megahertz and 20 Hz. Next question. The peak output of a tuned amplifier at 6 megahertz has a quality factor of 60. What will be the bandwidth and 3 dB frequencies? So the bandwidth of tuned amplifier is difference between 3 dB frequencies, and these 3 dB frequencies are symmetrical about resonant frequency. As these 3 dB frequencies are symmetrical, then lower cutoff frequency F1 is equal to this center frequency FC, lower cutoff frequency F1, upper cutoff frequency F2. Lower cutoff frequency F1 is equal to Fc minus bandwidth by W. So this is the bandwidth at 3 dB frequencies. Here it is the bandwidth at 3 dB frequencies. Now maximum voltage is Vm and 3 dB voltage is Vm by root 2. Maximum power is P and 3 dB power is P by 2. These 3 dB frequencies are also called half power frequencies, where this width will become the bandwidth. Now bandwidth is symmetrical. So here it is bandwidth by 2. So this side it is bandwidth by 2. So the bandwidth is symmetrical at the resonant frequency. Okay. Now in the question they have given quality factor. Quality factor is 60 and resonant frequency is 6 megahertz. So we know that quality factor is equal to resonant frequency by bandwidth. So from this the bandwidth is resonant frequency 6 megahertz, 6 into 10 power 6 by quality factor 60. So the bandwidth is 100 kilo. So it will be 10 power 5. So 10 power 5 can be written as 100 kilohertz. Now the bandwidth is symmetrical along with the center cutoff frequency. So that is lower cutoff frequency F1 is center frequency 60 megahertz, 60 into 10 power 6 plus bandwidth by 2, that is 100 by 2, 50 kilohertz. Similarly, upper cutoff frequency FH, that is F2, as per this question, as per the diagram, it is represented with F2, upper cutoff frequency. F2 is equal to 60 into 10 power 6. Here it is minus and here it is plus 50 kilohertz. So that is the values are 6.05 megahertz, 5.95 megahertz. The bandwidth is 100 kilo, upper cutoff frequency 6.05 and lower cutoff frequency 5.95. Correct option is D. Next question. The majority carrier lifetime and diffusion constant in a semiconductor material are 100 microsecond and 100 centimeter square per second. So given carrier lifetime tau is 100 microsecond and diffusion constant D is 100 centimeter square per second. Now the diffusion length, the formula for diffusion length is L is equal to square root of D tau. So square root of diffusion constant, that is 100, and carrier lifetime 100 micro 10 power minus 6. So here it will be 10 power 4, 10 power minus 6, that is 10 power minus 2, 0.1, 10 power minus 1 centimeter. So correct option is 0.1 centimeter. So diffusion length is 0.1 centimeter. Next question. In an the intrinsic concentration in a semiconductor is 10 power 13 per centimeter cubed when it is doped with donor type impurities. So donor means N type impurities, pentavalent impurities. So donor impurities are pentavalent fifth group, pentavalent impurities. It results in N type semiconductor. Pentavalent donor impurities, It converts intrinsic semiconductor to n-type semiconductor. In n-type semiconductor, the concentration of electrons is much higher when compared to the concentration of holes. Now in the question they have given majority carrier concentration. Therefore, electrons are majority carriers in n-type semiconductor as well as holes, that is p minority carrier concentration in n-type semiconductor. So majority are electrons n and minority carriers are holes, that is p. So we know that as per mass action law, under thermal equilibrium, the product of free electron concentration and free hole concentration is equal and is equal to square of intrinsic concentration. So now apply this formula here, that is P is equal to P approximately equal to Ni square by N, that is Ni square, it is 10 power 13 whole square by 10 power 17. So 10 power 13 whole square is 10 power 26 by 10 power 17. So its value is 10 power 9 per centimeter cube. Therefore, whole concentration is 10 power 9 centimeter cube. Correct option is D. Next question. As per the Hall effect, if specimen carrying current I is placed in a transverse magnetic field, a specimen carrying current I is placed in transverse magnetic field, then the electric current induced or voltage induced in a specimen is in the direction of perpendicular to both current and magnetic field. So let us see Hall effect here. When a current carrying conductor is placed in a transverse magnetic field, the induced voltage because of this induced voltage, currents will flow. This induced voltage is in the direction perpendicular to the both magnetic field and current. So the expression for Hall voltage VH is equal to RH BI by W, where I is a current flowing through the specimen, B is a magnetic field, applied magnetic field, that is RH is Hall coefficient, which is equal to 1 by NQ, that is 1 by rho, 1 by charge density, where W is the thickness of the crystal or width of the specimen, and this Hall voltage VH is negative for a metal or n-type semiconductor, and this VH is positive for p-type semiconductor, and the Hall voltage, induced Hall voltage, this induced Hall voltage VH is 0 for intrinsic semiconductor, and induced Hall voltage VH is positive for p-type semiconductor and negative for metal and n-type semiconductors. Here the current and the magnetic field as well as induced current, applied current, induced current and magnetic field all are perpendicular to each other. Next question. In a PN junction, the space charge capacitance is proportional to V power minus n. This space charge capacitance or depletion capacitance or transition capacitance, it occurs in when the diode is in reverse bias. This space charge capacitance is proportional to 1 by V power n. So where V is the applied voltage in reverse bias, and where the value of n is 1 by 2 for step junction, 1 by 3 for linearly graded junction, and 1 by 2.5 for diffused junction. So that is correct option is A. For step junction it is 1 by 2, for linearly graded junction 1 by 3, and for diffused junction 1 by 2.5. Next question. The H parameter equivalent circuit of a junction transistor is valid for. So this H parameter equivalent circuit of a junction transistor is valid for low frequency small signal operation, and various hybrid parameters are HI input impedance, HF forward current gain, HO output admittance, and HR reverse voltage gain. So correct option is low frequency application as well as small signal operation. Next question. In a modern MOSFET, the material used for the gate is, so it is heavily doped polycrystalline. This heavy doped polycrystalline silicon is also called polysilicon. The other name for this is polysilicon. Correct option is C. Next question. Thermal runaway is not possible in FET because as the temperature of FET increases, what about mobility? So thermal runaway. So BJTs are thermally unstable. So in BJT thermal runaway exists. So BJTs is thermally less stable. Whereas this field effect transistor, there is no thermal runaway. FETs has good thermal stability due to absence of minority charge carriers and are less affected by temperature changes. In FET, as temperature increases, in field effect transistor, junction field effect transistor, as temperature increases, this mobility gets decreased. So there is no thermal runaway. Hence, no thermal runaway. So correct option is B. So in field effect transistor, as temperature of FET is increased, the mobility gets decreased. Next question. An operational amplifier has a slew rate of 100 volt per microsecond and frequency of 10 megahertz. And what is the maximum peak value of the sine wave output voltage? So for an operational amplifier, for an op amp, slew rate is defined as the maximum rate at which op amp output changes. It is measured in volt per microsecond. The slew rate is measured, units for this slew rate is volt per microsecond, and this slew rate indicates how fast, how quickly the op amp output can follow with the changing input signal. And the formula for slew rate is 2 pi f Vm. Slew rate is equal to 2 pi f Vm. So given the slew rate is 100 volt per microsecond, 2 pi, what's the frequency? It is 10 into 10 megahertz, 10 into 10 power 6. So from this into Vm, so maximum voltage of the signal. So from this Vm is equal to, so this is slew rate is 100 volt per microsecond. So it can be written as 100 by 10 power minus 6. So 100 by 10 power minus 6. Now the voltage Vm is 100 by 2 pi into 10. So that is 10 by 2 pi, 5 by pi. So pi value is 3.1417. So from this slew rate is 1.6 volts. Approximately it is, sorry, the maximum output voltage, it is 1.6 volts. Next question. In a digital to analog converter, the resolution is 50 millivolts. So 50 millivolts is the resolution and the total maximum output voltage is 10 volts. The number of bits required is this digital to analog converter resolution delta V naught is equal to VFS by 2 power n minus 1, where n is the number of bits. Resolution 50 millivolts and the maximum voltage, that is full scale output voltage, is 10 volts. So substitute this formula here. So 50 into 10 power minus 3 is equal to full scale output voltage 10 volts by 2 power n minus 1. So from this 2 power n minus 1 is equal to 10 by 50 into 10 power minus 3, it will become 10 cube. So that is 2 power n minus 1 is equal to 200. So from this the value of n is 2 power n is 201. 2 power n value is 201. N is equal to log 201 base 2. It is around 7.5 something, but n must be a smallest possible next higher integer. Therefore, the value of n is high, 8. The correct option is 8. It is not 7 because it should be greater than or equal to, n should be greater than or equal to log 201. So correct option is 8. Next question. In a 4-bit weighted resistor digital to analog converter, the resistor value corresponding to LSB is 32 kilo ohm. So resistance for LSB is 32 kilo ohm. And what is MSB resistance? So therefore, in a weighted resistor DAC, MSB resistance is equal to LSB resistance by 2 power n minus 1. So LSB resistance by 2 power n minus 1. Therefore, MSB resistance or MSB is equal to LSB resistance or LSB, that is 32 kilo ohm by 2 power n minus 1. 32 kilo 2 power n minus 1. Here n number of bits n is 4 bit. 4 bit weighted register DAG. So that is 2 power 4 minus 1, 16 minus 1, it is 15. So 32k by 15, 1 5. So its value is, sorry, it is 2 power n minus 1. So it is 2 power 4 minus 1. So that is 2 cube. 2 cube value is 8. So now it is 4 kilo ohm. So it is 4 kilo ohm. Next question. Which one of the following unlocked to digital converter? The conversion time is practically independent of amplitude of the message signal. So that is successive approximation type. For successive approximation type unlocked to digital converter, the conversion time is practically independent of message signal, because this successive approximation ADC converter uses binary search algorithm to rapidly convert analog signal to a digital equivalent by iteratively comparing the input voltage with a reference voltage. And the conversion time, the definition for conversion time is the amount of time taken by the analog to digital converter to convert analog input to the digital output. So correct option is A. Next question. Which of the following represents E316? So therefore choose option D. So from option D, they have given 200, 200 base 16. So directly subtract 200 base 16, 11D. So perform hexadecimal subtraction. So take one borrow here, it will become F, and take one borrow here, it will become 16. Now it will be 1 here. So 16 minus D. So the value of D is 13. So it is 13. So 16 minus 13, its value is 3. And F minus 1, it is E. So 1 minus 1, it will become 0. So 1 minus 1, it will become 0. So E3 16. So this option D, direct subtraction, will result 16, or otherwise so E3 16. So convert this hexadecimal to decimal number. 14 into 16 power 1 plus 3 into 16 power 0. So its value is 224 plus 3, 227. Next choose option D. So from option D, 200 base 16, its value is 16 square into 2. So that is 256 into 2, 5112. Next 11D base 16. So that is 16 square into 1 plus 16 into 1 plus the D value. So D value is 13. So its value is 285. 16 square is 256. Now 512 minus 285. 512 base 10 minus 285 base 10. So its value is 227. So this is satisfied. Correct option is D. Next question. The gray code for the given binary code is, so given binary code is 1 0 1 0 1 1. To convert gray code to binary code, so the given code is binary code. So in this question they have given conversion of binary code to gray code. So to convert binary code to gray code, take MSB bit as it is and perform XOR operation of these 2 bits. So that is 10 is 1, and XOR operation of 2 bits. 10 is 1, again XOR operation 1, and then 10 is 1 and 11 is 0. So correct option is B. So binary code to gray code. So theory here it is given is gray code to binary code conversion. So reverse process. So the question here is, so convert binary code to gray code. So take MSB bit as it is and perform two consecutive bits XOR operation, which results a gray code. So correct option is B. So once again, the binary code is 101011. This is a binary code. Take MSB bit as it is and perform XOR operation between two bits. So 10 it is 1 and 01 again it is 1. XOR of 01 is 1 and again 10 it is 1, 10 it is 1, again 11 it is for 11 it is 0. XOR operation of 11 is 0. So this is binary code and this is gray code. Correct option is B. Next question. The number of Boolean functions of 3 variable is. So here the number of variables n is 3. The number of Boolean functions or switching functions possible are 2 power n. So that is 2 power 2 cube. So 2 power 8. 2 cube is 8. 2 power 8 is 256. The number of Boolean functions or switching functions possible is 256. Next question. The output of logic gate is 1. The output of logic gate is 1 when all the inputs are at logic 0. So if all the inputs are at logic 0, for OR gate, all the inputs are 0, output is 0. For XOR gate, if all the inputs are 0, output is 0. For AND gate, if all the inputs are 0, output is 0. But for NOR gate, if inputs are 0, output is 1. For XNOR gate, if all inputs are 0, output is 1. Therefore, the correct option is D. For NOR gate as well as for XNOR gate, for XNOR gate, if all inputs are 0, the output is 1. Correct option is D. Next question. A signal y of t is equal to a cos 500t plus 30 degrees. So it is a cosinusoidal signal, which is an example for power signal, because all periodic signals are power signals. A signal is said to be a power signal if and only if total power is finite. The power for this signal is P is equal to A square by 2 and energy is infinite. So energy of this signal is infinity. For this signal it is infinity. So for a signal y of t is equal to a cos omega t plus phi. So where omega is the angular frequency, phi is the phase angle, a is the amplitude of the signal. For this signal, power is a square by 2 and energy is infinity. It is a periodic signal. It is a power signal with power is finite value, that is a square by 2, and energy is infinite value. So correct option is B. It is a example for power signal. Next question. Fourier series of a periodic transform. So this Fourier series of a periodic transform, it express the statement 1 is it express the given periodic waveform as a combination of DC component, sine component, cosine waveforms of different harmonic frequencies. So statement 1 is correct. The amplitude spectrum is discrete. So it is having Fourier series of a periodic transform is having discrete amplitude spectrum. Next, the statement 3. The evaluation of Fourier coefficients gets simplified if the waveform symmetries are used. So this is also true. Next, statement 4. Amplitude spectrum is continuous. So this is false. So amplitude spectrum is discrete. The amplitude spectrum and phase spectrum of phase spectrum occurs at discrete frequencies. Fourier series of a periodic transform have amplitude spectrum at discrete frequencies as well as phase spectrum at discrete frequencies. It is not continuous. So correct option is 1, 2, 3. So 1, 2, 3 statements are correct and this statement 4 is wrong. Next question. The Nyquist rate of a signal y of t is equal to cos 2000 pi t plus 3 sin 6000 pi t. So in the question they have asked Nyquist rate. So Nyquist rate is 2 times of highest frequency component in the signal. Let us compare the given signal with cos 2 pi f1 t plus 3 sin plus a sin. So it is standard expression is amplitude a sin 2 pi f2t. Here frequency f1 is 1000, that is 1 kilohertz. Frequency f2 is 3000, that is 3 kilohertz. Now Nyquist rate is 2 times of highest frequency component maximum frequency component maximum of f1 comma f2. So 2 into maximum of 1 kilo comma 3 kilohertz. So maximum value is 3 kilohertz, that is 2 into 3 kilo. Nyquist is 6 kilohertz. So Nyquist rate is 6 kilohertz. The formula for Nyquist rate is, this is the formula. Next question. The Laplace transform of a delayed impulse function delta of t minus 1 is. So we know that the Laplace transform of impulse signal delta of t is equal to 1. But time shifting property delta of t minus t naught is equal to e power minus st naught. Here the value of t naught is 1. So therefore Laplace transform of delta of t minus 1 is e power minus s. So that is exponential of minus s. Next question. The jet transform and Laplace transform are related by. So jet transform and Laplace transform. So jet transform is an essentially a discrete time equivalent of Laplace transform. It is given as z is equal to e power st. So z is equal to e power st, where s is a complex frequency variable in Laplace transform, z is a complex variable in z transform, and t is a sampling period. Now st is equal to ln of z, where s is equal to ln of z by t. S domain variable is s is equal to ln of z by t. S is equal to ln of z by t. Correct option is A. Next question. The noise figure of a receiver is 1.6 at 17 degree centigrade. So here it is given in centigrade. So convert this centigrade into Kelvin. So add 273 degrees. So it will convert centigrades to Kelvin. So 273 plus 17 degree, it will give 290 Kelvin. In the question they have asked equivalent noise temperature T is equal to, so T naught into noise figure minus 1. In the question they have given noise figure is 1.6. Therefore equivalent noise temperature T is equal to T naught 290 noise figure 1.6 minus 1. So that is 290 into 0.6, its value is 174 Kelvin. So this is equivalent noise temperature T is equal to 174 Kelvin. So correct option is C.